Hi everyone, this is Sarfahan. Let's start paper 2 of AS level chemistry, February-March 2024, variance 22. The duration of this paper is 1 hour 40 minutes. We need to attempt all the questions. We need to show working where calculation is needed, and we need to use appropriate units. The total mark for this paper is 60. Let's start the paper. Question number 1. Bismuth is an element in group 15 of the periodic table. By the way, the symbol of bismuth is capital B and a small I, that is Bi. Okay. Bismuth has metallic bonding, which means bismuth is basically a metal, and so it exhibits metallic bonding. Or metallic bonding has two characteristic features. The first one is contain positive ion and C of electron. C of electron is also called C of delocalized electrons. C of delocalized electrons, also called bonding electrons. Draw a label diagram to show the metallic bonding in bismuth. Again, in this diagram, we need to show the positively charged ion and the C of delocalized electrons. So that's an easy task. So this is positively charged ion. Okay. And we need to mention electrons. So we need to mention electrons between these two positively charged ions so that they cannot repel to each other. This is electron, 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 and electron. Between these two cations, also electrons. Between these two, also electrons. All right. So two electrons cannot join together because of repulsion. Similarly, we cannot show a diagram in which two positively charged ions repel each other or two electrons repel each other. So we need to show the electrostatic attraction in which positively charged ion can easily attract delocalized electrons or bonding electrons. Okay. So since it is a 1 mark, so I think it's more than enough, but I don't know the marking scheme. So let's label the basic information. This is positively charged ion. And this is C of electron or bonding electron. Okay. Let's come to the B part. Bismuth reduces water to form bismuth oxide, which has a molecular formula of Bi2O3. A colorless gas that ignites with a squeeze pop also forms. That's the issue, that it burns with a pop sound. Okay, so this colorless gas must be hydrogen gas because hydrogen burns with a pop sound, and hydrogen is also a colorless gas. Now the question is, construct an equation for the reduction of water by bismuth. Again, easy task. Bismuth is Bi. It is reacting with water, converting into bismuth oxide, which is Bi2O3, and hydrogen gas. See, we have 3 oxygen atoms here, so we need to mention 3 here. We have 6 hydrogen atoms here, so we need to mention 3 hydrogen here. How many bismuth here? 2, so we need to put 2 here. That's the balanced chemical equation, guys. Bi2O3 is a yellow insoluble solid, insoluble in water. That means, okay, it has a yellow color, and that melts at 1090 Kelvin. melts, the melting point is higher melting point. If this melting point is higher, this gives two different sort of information. The first one is, oh, one more thing. It has a higher melting point, fine. But this gives three different sort of informations. The first one is it exhibits ionic bonding because ionic compounds have high melting point. All right. Second thing, in molten state, it conducts electricity because of the presence of free mobile ions. And all ionic compounds can conduct electricity in molten state because of the presence of free mobile ions. Okay. Second information is molten state exists in molten state, and the next one is that it must be as a giant crystal lattice structure. So this compound has a higher melting point. That indicates two basic information. The first one, it exhibits ionic bonding, and the second one is it has giant crystal lattice structure. Since it has an ionic bonding, so all ionic compounds can form, can exist in molten state. And in molten state, we have free mobile ions, which is why this compound can conduct electricity as well. So on the basis of this entire information, examiner is asking, deduce the structure and bonding of Bi2O3, explain your answer. Okay, why it has a higher melting point? So in terms of structure and bonding, we need to give answer as per my lecture. So let's start. Bi2O3 exhibit ionic bonding. And has a giant crystal lattice structure. So more energy is needed to overcome strong electrostatic attraction so it has high melting point. All right. Next, it has high melting point and also exist in molten state. Next part of the question, Bi2O3 can be used to form NaBiO3 as shown in equation 1. Okay, deduce the oxidation number of bismuth in Bi2O3 and in NaBiO3. So first we need to find the oxidation state of bismuth in Bi2O3. So my bad, Bi2O3. So let's suppose bismuth is X. So we have two bismuth in the formula, so we need 2X. The charge on the oxygen atom is -2. We have 3 oxygen atom into 3. Since the molecule is neutral and has no charge, which is Y equals to 0, then 2X equals to +6, then X equals to +3. So the oxidation state of bismuth in Bi2O3 is going to be +3. Similarly, we need to find out the oxidation state of bismuth in this compound. So in this compound, NaBiO3, bismuth, let's suppose is X, because we need to find out its oxidation state. Sodium belongs to group 1, so it has +1 charge. Oxygen belongs to group 16, so it has -2 charge. We have 3 oxygen atom into 3. Since the molecule is neutral and has no charge, which is Y equals to 0. And therefore, the oxidation state is going to be +5. Okay. So the next is identify the reducing agent in reaction 1. Reducing agent, substances which causes another substance to be reduced are called reducing agent, and oxidizes themselves, right? That's the definition. That's the conceptual definition of reducing agent. Causes another substance to be reduced and oxidizes themselves. So obviously, in that scenario, Bi2O3 would be the reducing agent, because during the reaction, its oxidation state is decreasing, which means during the reaction, So oxidation state, no, I don't think so. Let me check again. Oxygen has an oxidation state of 0. Over here, it has -2. So basically, oxygen is decreasing. So technically, oxygen is an oxidizing agent, right? And I think bismuth is going to be the right answer. This one should be the right answer, because its oxidation state is +3 and it's increasing. No. No. So reducing agent causes another substance to be reduced. So this is basically the reducing agent, because it reduces oxygen into oxide ion, right? And oxidizes itself, which is why its oxidation state during the chemical reaction increasing. So I was right initially. Bi2O3 is basically the reducing agent. All right. I hope it makes sense to you. Let's move on to the next page. NaBiO3 is an oxidizing agent. Okay. With similar properties of KMnO4. All right. Both KMnO4 and this compound is an oxidizing agent. Let's talk about oxidizing agent here. Oxidizing agent are those substances which causes another substance to be oxidized. Another substance to be oxidized and reduces themselves. Okay. Figure 1.1 shows an example, the use of NaBiO3 as an oxidizing agent. This is an oxidizing agent. This is our X. Now this X has two, this X belongs to alcohol family or alcohol homologous series, because both are alcoholic functional groups, right? But you have to notice one thing. This is secondary alcohol and this is tertiary alcohol. How can we decide which one is primary, secondary, or tertiary alcohol? That's an easy task. OH attached to carbon, if it has one hydrogen atom, then it means it is secondary. If it has no hydrogen atom, then it means it is tertiary. So this must be the tertiary alcohol and this must be the secondary alcohol. So when you are reacting this compound X with this reagent, it forms propane 2-on and ethanol. By the way, this is propane 2-on, or you can say propanol. And this compound is basically an aldehyde. So 2 carbon with an aldehyde functional group is going to be ethanol. Explain the term oxidizing agent. So that's what we have done here. Substances which causes another substance to be oxidized are called oxidizing agent. And reduces themselves. That means during the reaction they will gain electron. So technically, oxidizing agents are electron acceptors. They will accept electrons during the reaction. Okay. Compound X forms when methyl butene reacts with KMnO4. First of all, I need to find the structure of methyl butene. So we have 1, 2, 3, 4 carbon atom because it has butene. But means we have 4 carbon. 2-ene means that second carbon has double bond. Then methyl indicates that the second carbon has CH3 group as well. So that's the structure of 2-methyl butene. All right. So basically, it is an alkene. And when you react alkene with KMnO4, it will give you diols, right? Because this compound X shows that we add 2 OH group to the alkene. So if you add OH group to the double bonded adjacent carbon atom, you will get diols. And if you get diols, then it means KMnO4 is used. So when this compound is treated with KMnO4, you will get diol, and the structure of diol is this, right? So what are the essential conditions for this reaction? So KMnO4 in this situation must be cold, dilute, acidified. So whenever cold, dilute, acidified KMnO4 is used, you will get diol, and in that OH attached to this carbon, OH attached to this carbon, one bond removed. So it's going to be compound X here. All right. Next, complete table 1.1 to show what is observed when compound Y and Z react separately with the named reagent, sodium carbonate. Sodium carbonate. Sodium carbonate can only react with carboxylic acid. Now, this compound has no carboxylic acid functional group. This compound is an aldehyde. It has no carboxylic acid functional group. That means neither Y nor Z reacts with sodium carbonate. So I will write no reaction here. Okay. Y and Z, Y and Z. Okay. Alkaline aqueous iodine, according to my lecture, alkaline aqueous iodine works effectively in aldehyde and ketone whenever you have CH3CO group available in the molecule. So we really need to check whether this group is there in both Y and Z. Let's check. This is CH3, this is C, this is double bond O. So CH3CO group is here, which means Y can give you iodoform test very easily. That will give you yellow precipitate. Similarly, this is CH3, this is C, this is double bond oxygen. So this compound also contain CH3CO group, which means it can also give you iodoform test, positive test of iodoform test. That means it will give you yellow precipitates. So in both Y and Z will get yellow precipitates because both the compounds contain CH3CO group. All right, one more thing. This is ketone, this is aldehyde, and both these compounds belongs to carbonyl compounds. All right. because they have carbonyl groups. And since both are carbonyl compounds, which means both of them can react with 2,4-dinitrophenyl hydrazine, and therefore you will get yellow-orange precipitates. Same here. Let me copy this. All right. Okay. Again, it is a ketone and it is an aldehyde. So ketone cannot give positive test of tolerance reagent, whereas aldehyde can react with tolerance reagent and gives you a positive result of silver mirror, right? So in this scenario, no reaction because ketone cannot react with tolerance reagent. And when aldehyde reacts with tolerance reagent, you will get silver mirror. And if you left silver mirror for a very shorter period of time, it will oxidize in the presence of air and will give you the black precipitates of silver 1 oxide, all right? Or black precipitates and black precipitates of silver 1 oxide, which is a formula of Ag2O. Anyhow, let's move on to the next. Construct an equation for the reaction of Z with sodium borohydride. Guys, sodium borohydride is a reducing agent, which means it is a reduction reaction. Whether it's aluminum hydride or sodium borohydride, all reducing agents are represented by this hydrogen atom. It is also called nascent hydrogen. So we have Z, and Z is what? Ethanol. So ethanol has a formula of CH3 CHO. Treating it with nascent hydrogen, that is atomic hydrogen, that is your reducing agent, which is sodium borohydride. Obviously, if you react aldehyde with a reducing agent, according to synthetic route, according to my lecture, it's going to be converted into primary alcohol. All right, so it's going to be converted into primary alcohol, that is CH2OH. Now, total how many hydrogen atoms here? 4. And total how many hydrogen atoms here? 6. That indicates in order to balance the equation, we need to put 2 here. So total number of carbon atoms here, 2 carbon, 6 hydrogen, 1 oxygen. Total number of carbons here, 2. Total number of hydrogen atoms, 6. And total oxygen atom is 1. So that's the balanced chemical equation, guys. I hope it makes sense to you. Oh, next, my goodness, calculation. NaBiO3 is basically an oxidizing agent. That's what the examiner told you about this compound. It is an oxidizing agent. All right. And it is used to determine the concentration of Mn2 plus ions. By the way, lower oxidation state metal ions are always reducing agent. So this one is basically the reducing agent this time. Okay. The ionic equation for this reaction is shown in equation 2. According to the ionic equation, this reducing agent has 2 moles, whereas this oxidizing agent has 5 moles, which means 2:5 ratio exists between these two species, right? A student uses the following procedure in an experiment. 100 cm cube of a saturated solution of this reducing agent to a volumetric flask. Add distilled water to the flask to make 1 dm cube diluted solution. This 1 dm cube diluted solution is basically the 1000 cm cube diluted solution. All right. After that, I'll take out 25 cm cube from this solution. And then the solution has a concentration of 0.1 mole per dm cube NaBiO3. Now, 25 cm cube sample of the diluted solution of Mn2 plus reacts completely with exactly 21.50 cm cube of 0.1 mole per dm cube. This calculate the concentration in mole per dm cube of Mn2 plus ion in a saturated solution. Again, saturated solution, and that saturated solution was 100 cm cube. So show your working. Since we know the concentration of and volume of oxidizing agent, which means first we need to find out the moles of NaBiO3. We have 21.50 cm cube. We have 0.100 mole per dm cube divided by 1000. So it's going to be 2.15 into 10 to the power, I think so, minus 21.5 into 0.1 divided by 1000 is going to be 2.15 into 10 to the power minus 3 moles. Now, according to the equation, Mn2 plus and BiO3 negative, yeah, has 2:5 ka ratio. So if the number of moles of BiO3 minus is times 2.5 into 2.15 into 10 to the power minus 3, how much moles of Mn2 plus? So basically we need to cross multiply them. So moles of Mn2 plus in 25 cm cube is into 2 divided by 5. So it's going to be 8.6 into 10 to the power minus 4 moles. Now look, that was 1000 cm cube solution, and from that I took 25 cm cube sample, right? That means 25 cm cube sample contain 8.6 into 10 to the power minus 4 moles. So if we had 1000 cm cube diluted solution, so amount would be how much? 0.0314 moles. So whatever you have calculated in 1000 cm cube diluted solution, the number of moles will remain same in 100 cm cube. 1000 cm cube sample contains 0.0314 moles. So in 100 cm cube, it would be how much? So concentration of Mn2 plus is going to be how much? 0.03. Oh my goodness. Wait, hold on a second. 0.0344. Okay, this is a slight error here. This is 0.0344. Similarly, it must be 0.0344. Guys, you need to check. You need to double check your calculations. Okay. So into 100 divided by 1000. So it's going to be what? Hold on. Let me check my calculation again. 2.15 exponent minus 3 multiplied by 2 divided by 5. You will get this. This much into 100 divided by 1000. Oh, my bad. I got the point. That's not 1000, that's actually 100. Okay, whatever we have calculated in 1000 cm cube diluted solution, the mole will remain same in 100 cm cube. So 100 cm cube sample contain 0.03 mole. In order to calculate the concentration, we need to compare it with 1000. So concentration is going to be how much? Now that's the issue. 0.0344 into 1000 divided by 100. So it's going to be 0.344 molar. Molar means mole per dm cube. So it's going to be 0.344. That's question number 1. Oh my goodness. That's question number 1. Let's start question number 2. Chlorine belongs to group 17 elements, also called halogens, reacts with many elements and compounds to form chlorides. Table 2.1 shows about information about some chlorides of period 3 elements. Formula of chloride. If you have sodium, the formula of chloride is going to be NaCl, which is sodium chloride. For magnesium, it must be magnesium chloride, which is NaCl2. And for silicon, it must be silicon tetrachloride, which is SiCl4. By the way, ionic compound, which means it is also solid, it is also solid, it is covalent molecule, it must be liquid. All right. That the state symbol is not asking, but it's all right. That's good for the revision. Structure of chloride. Since it is ionic compound, it has a giant structure. It is also ionic compound, it has a giant structure as well. And since it is a covalent molecule, so it has a simple molecular structure. Okay. Now the next is bonding of chloride. Obviously, ionic compound exhibit ionic bonding. MgCl2 is also ionic compound, exhibit ionic bonding. And SiCl4 has a simple molecular structure, which means it exhibits covalent bonding. A sodium chloride is an ionic compound. When you place it in water, it will dissolve and give you a neutral solution of pH 7 according to my lecture. Magnesium chloride, because of high charge density of magnesium ion, give you a slight acidic solution of pH 6.2 when you place it in water, right? Now, SiCl4 has a vacant d orbital, and because of that vacant d orbital, it can easily hydrolyze with water, and that will give you a strong acidic solution of pH 3, and that strong acidic solution also conducts electricity because HCl is going to be the final product in this case, right? Let me tell you, SiCl4, because of vacant d orbital, can easily hydrolyze with water, and you will get what? White precipitates of SiO2 and misty fumes of HCl. Now, these misty fumes are soluble in water, and this will give you a strong acidic solution of pH 3, and also this conducts electricity, okay? Because it is an electrolyte. Oh, so I have completed the table, okay? Is there anything left? No. Let's move on to the B part. When chlorine reacts with cold NaOH, okay. Let me write the equation first. When we use cold NaOH, and if you involve it with chlorine, it undergoes a special type of reaction due to which chlorine exists in two different oxidation states in the same reaction. And this reaction is going to be the disproportionation reaction, right? Because chlorine exhibits in two different oxidation states. Anyhow, chlorine is both oxidized and reduced. That's the point. Chlorine is reduced in this case because chlorine changes its oxidation state from from 0 to -1. Whereas in this conversion, chlorine changes its oxidation state from 0 to +1. That means in this reaction, it is reduced. And in this reaction, it is getting oxidized. So chlorine is oxidized and reduced in the same reaction. State the type of redox reaction in which the same species both oxidize and reduce. According to my lecture, it's going to be disproportionation reaction. Okay, identify G. So G is basically NaClO, and NaClO is basically sodium chlorate 1, and 1 is the oxidation state of chlorine in this compound, right? Write an equation for the reaction between chlorine and hot NaOH. Again, easy task. This is hot NaOH. It is reacting with chlorine gas, converting into sodium chloride. This time, sodium chlorate 5 is formed, which has a formula of NaClO3, and this water molecule is also formed. All right, that's a balanced chemical equation, guys. This reaction is also this proportionation reaction because chlorine is getting reduced in this conversion, whereas chlorine is getting oxidized in this conversion. So ye reduction and this one is oxidation. Describe fully what is observed when silver nitrate is added to aqueous solution of chloride of sodium. The chloride of sodium is basically NaCl, and silver nitrate has a formula of AgNO3. If you mix these two substances, obviously a chemical reaction takes place in which sodium nitrate is formed, which will give you a colorless solution. So this is going to be the filtrate, and AgCl is also formed, and AgCl has a white precipitates, and these white precipitates of AgCl are insoluble in water. So basically this white precipitates, you can treat them with dilute aqueous ammonia. So when white precipitates of AgCl is treated with dilute aqueous ammonia, then white precipitates are soluble and give you a colorless solution. And the formula of a colorless solution is going to be like this. Okay. I hope it makes sense to you. What's the function of ammonia in this reaction? Ammonia is used to dissolve precipitates. Okay. And according to my lecture, ammonia and silver metal ion exhibit dative bonding. And how many dative bonds are formed? 2. Next part of the question is, an excess of chlorine reacts with phosphorus to form PCl5. PCl5, okay? That's the reaction. Phosphorus is always P4, reacting with chlorine, converting into PCl5. Let's make the equation. So we need to put 4 here. How many chlorine atoms? 20. So we need to put 10 here. So that's the balanced chemical equation for this reaction, okay? PCl5 is a simple molecule, which means it exhibits covalent bonding. Because it has a simple covalent structure, or it has a molecular structure. In the gas phase. It also exists in solid to form 2 ions, PCl4 plus and PCl6 minus. Oh, okay. How come this PCl6 minus is formed? That's a very, very important information. See, PCl5, phosphorus belongs to period 3. So it contained vacant d orbital. And due to the presence of this vacant d orbital, it can form PCl6 minus. Okay, so that's the reason why PCl6 is formed and how PCl6 is formed due to the presence of vacant d orbital. Complete table 2.2 to identify the shapes of each these species. Okay, okay. So we have done this in class. Let's try that lecture again. How many chlorine atoms around phosphorus? 4. So we need to make the structure like this. Okay. We know phosphorus belongs to group 15, and so it has 5 valence electrons. And those 5 electrons should involve in the chemical bonding, right? So let's distribute those 5 electrons here. 1, 2, 3, This electron has been lost. So I need to remove this electron from the diagram. After that, how many single bonds around phosphorus atom? 4 single bonds around phosphorus atom. Is there any lone pair around phosphorus? No, there is no lone pair. So if you add these two values, you will get 4. First line is always represent s orbital. The remaining line represents p orbital. So the hybridization is going to be sp3. So whenever you have 4 single bond and a 0 lone pair with this hybridization, geometry is going to be tetrahedral. So that's the tetrahedral shape. Okay. My goodness, PCl6 minus. Okay. PCl6 minus. So we need to make 6 covalent bonds around phosphorus because there are 6 chlorine atoms around it. So how many valence electrons around phosphorus? 5, because it belongs to group 15. So 1, 2, 3, 4, 5. And obviously, this must be the chloridine. So that's the chloridine which is involved in the chemical reaction with the vacant d orbital of phosphorus, and hence this PCl6 negative is formed. So how many single bond around phosphorus in this case? 6. Is there any lone pair around phosphorus? No. So total we have 6. Let's make 6 lines in order to understand the hybridization. The first one is s orbital. The 3 lines shows p orbital. The remaining 2 lines shows d orbital. So hybridization is going to be sp3d2 according to my lecture. Whenever you have 6 single bond and a 0 lone pair with sp3d2 hybridization, geometry is going to be octahedral. And octahedral geometry, you have an angle of 90 degree. And if you have tetrahedral geometry, you have an angle of 9.5 degree. That's the case we have discussed in the class. So it's PCl5, it's trigonal bipyramidal geometry or shape. Okay. PCl5. How can I decide PCl5? Let's make 5 chlorine atoms around phosphorus. Phosphorus belongs to group 5 of the periodic table. 1, 2, 3, 4, 5, which means around phosphorus we have 5 single bond and a 0 lone pair. So total is going to be 5. Draw the 5 lines. 3, 4, and this one is 5, right? The first line always shows s orbital. 3 lines shows p orbital. And this 1 line shows d orbital, right? So hybridization is going to be sp3d. So whenever we have sp3d hybridization with 5 single bond and a 0 lone pair, the geometry is going to be trigonal bipyramidal with an angle of 120 degree, also with an angle of 90 degree, if you remember. Let me draw the structure of PCl5. So this is going to be the 90 degree angle. Behind the plane, represented by dotted line. And this pyramid shows out of the plane, represented by this. And guys, you know, from here to here, the angle is 120 degree. From here to here, the angle is again 120 degree. Okay. So that was the structure, trigonal bipyramidal. Anyway, PCl5 reacts with J to form H3PO3. So PCl5, when react with water, it will turn to phosphoric acid, H3PO4. Now balance the equation. 5 HCl, how many hydrogen atoms so far? 8. To put 4 here. That's the balanced chemical equation. So J is water, because that's the only reagent through which we can form phosphoric acid when PCl5 react with it. Okay. And the type of reaction is again hydrolysis. We have discussed this entire information in chemical periodicity, right? Let's move on to the next page. Again, organic, my favorite part. Chlorine reacts readily with propene to form K, that is 1,2-dichloropropene. K can be used to form L. Okay. Okay. Now in the first reaction, chlorine has been added on the double bonded adjacent carbon atom, and so you will get this compound. Now when this compound reacts with another reagent, it will turn to an alkene. So this functional group is alkyl halide, and alkyl halide give you alkene through elimination reaction. If you remember, whenever any alkyl halide undergoes elimination reaction, you will get an alkene, right? And the reagents required for elimination reaction would be sodium hydroxide in ethanol under heat or reflux. Okay. And that's simple electrophilic addition reaction because alkenes always undergoes electrophilic addition reaction. And this reaction takes place at RDP. So that's electrophilic addition reaction, that's nucleophilic, that's elimination reaction. Complete table 2.2 to show the mechanism for the reaction of chlorine with propene, that's electrophilic addition reaction. Examiner is talking about include charges, dipoles, lone pairs of electron, and curly arrows as appropriate. So first of all, we need to make induced dipoles on the chlorine molecule, and these induced dipoles appear due to the presence of pi bond, right? As soon as the charges appear on the chlorine molecule, this pi bond will interact with this electron deficient chlorine so that a carbon chlorine bond is formed. At the same time, this chlorine removes in the form of chloridine. So this is going to be the carbon chlorine bond now. Now this carbon has H, this carbon has CH3. Now this carbon has positive charge. So whenever carbon carries positive charge, that's called carbocation. Now this carbocation will react with chloridine, and this chloridine is technically an technically a nucleophile, and this intermediate carbocation is acting as an electrophile. They will react together, and so that you will get a compound like this. Okay, I hope you get the point. Identify the reagents and conditions for reaction 2. Reagents: ethanolic, solution of NaOH, that's the reagent, and condition is reflux or heat and reflux. Draw one repeating unit of the addition polymer forms from L. So that's your L. Let me write it. Let me write it again so that we can make this structure. Oops. Now this is your double bonded carbon atom. So according to my lecture, make a double bonded carbon atom like this. Okay. Now this carbon has one chlorine and one CH3. This is CH3. Okay. Make it. This is one chlorine and this carbon has one CH3. All right. Now this carbon has two hydrogen atoms because this is CH2. This is your CH2. So we need to arrange these groups vertically always. Now in order to make a polymer, we need to shift this pi bond over here. Another pi bond shifts over here. That's the structure of one repeating unit of the addition polymer of L, right? So this is your compound L. It is converting into this polymer. That's the end of third question, I believe. Oh my goodness, second question. That's a lengthy paper. It's all right. Nitrogen is generally unreactive molecule, but it does react under certain conditions. Give two reasons to explain lack of reactivity of nitrogen. Well, we have discussed this in class. First, it is non-polar because difference of electron negativity of N2 molecule is 0, so it is non-polar. Also, contain triple bond. So what happens if it has triple bond? Because of the presence of triple bond, more energy is required to break that bond, which means it has a high bond energy. It has a high bond energy to break triple bond. Nitrogen can react with oxygen in internal combustion engine from a mixture of NO and NO2. Figure shows a reaction scheme involving nitrogen. So when nitrogen reacts with oxygen, it will give you oxides of nitrogen, that is nitric oxide, which is NO, also called nitrogen monoxide, and nitrogen dioxide. When nitrogen dioxide reacts with water, it will give you a products. Products, it's a plural, right? Products. Iska matlab you will get two different products. The first one is nitrous acid, which has a formula of HNO2, and the other one is nitric acid, which has a formula of HNO3. Guys, we have done this equation in nitrogen sulfur ka chapter. From here to here, it's basically reduction. And from here to here, it's basically oxidation. So technically, it is a disproportionation reaction because nitrogen is simultaneously oxidized and reduced in the same reaction, okay? And when NO2 combines with unburned hydrocarbon, you will get photochemical smog, which is also called peroxyacetyl nitrate, which in short, we can write PAN, PAN, okay? Write an equation to show the formation of a mixture of NO and NO2 in reaction 1. So N2 is reacting with oxygen, converting into NO and NO2. So how many nitrogen atoms here? 2. We have 2 nitrogen atoms. How many oxygen atoms here? 3. So we have 3 oxygen atoms here. 2 से 2 cancel, 3 oxygen. Give the formulae of the product of reaction 2. Nitrous acid and nitric acid. Examiner is talking about formulae, so we cannot write the name, okay? So it's HNO2 and HNO3. And obviously, guys, we need to make the balanced chemical equation, and for that, I need to put 2 here. That's the balanced chemical equation, okay? State 1 environmental consequences of reaction 3. It forms a photochemical smog. It forms a photochemical smog which causes global warming and lungs irritation. And also it is carcinogenic. Part C. The Haber's process involves the reaction of N2 and H2 to form ammonia. A catalyst is used which allows the process to be carried out at a lower temperature and pressure. Okay. By the way, Haber's process, according to my lecture, is exothermic and its value is -92. So forward reaction is exothermic. Ultimately, the backward reaction is going to be endothermic. Remember that. Use the information in C to complete table 3.1. All right. Okay. Seems like a strange question to me because enthalpy change of formation is not given, which means we need to find out these values. And according to my lecture, the standard enthalpy change of formation of diatomic molecules is always 0. And we need to find out the value by using this one. So let me draw the Haseloff cycle here. N2 plus 3H2, reversible sign, 2NH3. This value is -92. Since the formation data is given, so we need to start the Haber cycle to constituent elements, and for that I need nitrogen and hydrogen only. Draw an arrow like that. The enthalpy change of formation of nitrogen and hydrogen is 0. Put 0 here, and we need to find out the value of ammonia here. So we need to, it has to be 2x, right? Because we have 2 moles. So we need to make a, we need to draw an arrow in a clockwise direction so that we can arrange the values. Cycle, okay. So this value is going to be the positive one because it moves in a clockwise direction, and this value is going to be negative because it moves in an anti-clockwise direction according to my lecture. So take the value, this value and this value positive, this value is negative, equals to 0. Let me arrange it. Plus 0 plus minus 92 minus 2x equals to 0. Then minus 92 minus 2x equals to 0. Then x equals to how much? It's going to be 92 divided by 2. 92 divided by 2 is going to be 46. So it's basically minus 46 kilojoules per mole. Okay. Explain how the presence of a catalyst affect the reaction. So guys, catalyst provides an alternative pathway for a reaction by lowering the activation energy which means it increases the number of effective collision, hence rate of state and explain the effect, if any, on the rate of Haber's process as the pressure is lowered. Obviously, if pressure decreases, one more thing. In this part, examiner is specifically talking about rate of Haber's process. Examiner is not talking about the equilibrium position, right? So we really need to stick to the rate thing, okay? So that's what you have done in O levels as well. That's what you have done in chemical kinetics as well. If pressure decreases, molecules will move further away from each other. Distance between the molecules increases. Distance between the molecules increases. This weakens attractive forces. Slows down the movement. lowers the effective collision in a unit time. Thus, rate of Haber's process decreases. Oh, part D. N2F2 molecule has a double covalent bond between its nitrogen atom. N2F2. So examiner is saying that we have a molecule N2F2, and in that both the nitrogen atom has double bond between them, and obviously fluorine belongs to group 17, and all group 17 element forms one covalent bond. So technically it has to be one fluorine atom here. It has to be one fluorine atom with this nitrogen atom. Okay, so that's the structure actually examiner is talking about. Also, one more thing. Nitrogen atom belongs to group 15, so it has 5 valence electrons, right? Similarly, fluorine atom belongs to group 17, so it has 7 valence electron. So we need to distribute these electrons in such a way that we should have a double bond between the nitrogen atom. So first of all, let me distribute fluorine, 7 electrons of fluorine. So this is a 7 electron of fluorine, 7 electrons of fluorine here. Now distribute 5 electrons of nitrogen atom, 1, 2, 3, 4, and this one is 5. Similarly, distribute 5 electrons of nitrogen, 1, 2, 3, 4, and this one is 5. So this will give you this bond, this will give you another bond. Okay, this will give you single bond like this. This will give you single bond over here, right? I hope it makes sense to you. Deduce the hybridization of the nitrogen atom in N2F2. Okay. So examiner is specifically talking about the nitrogen atom. So the central atom would be nitrogen, right? So this nitrogen and this nitrogen has same chemical environment, which means we need to determine the hybridization of any nitrogen atom. The hybridization is going to be the same for the other nitrogen atom as well. So what we can do is, let's draw the structure here. N, double bond N, this fluorine atom, this fluorine atom. We know that nitrogen has 5 valence electrons. Distribute them. 1, 2, 3, 4, 5. Now we need to find out the hybridization, and for that double bond needs to be considered as a single bond. So around nitrogen atom, we have one double bond. So consider it as one single bond. Okay. This is going to be the another single bond. So around nitrogen, we have 2 single bonds, right? Around nitrogen, we have 1 lone pair. So total is going to be 3. So what we can do is, we need to draw 3 lines. The first line always shows S, or always represents S orbital. The remaining 2 line represents P orbital. So hybridization is going to be sp2. Okay. And according to my lecture, whenever we have 2 single bond and a 1 lone pair with sp2 hybridization, angle is going to be 117.5 degrees. Since examiner is not talking about angle, so you can ignore it. Okay. Draw a diagram of the pi bond between nitrogen atom in N2F2 and describe how it forms. I've given you ethine as an example in my lecture. So ethene as an example in my lecture, because ethene contained double bond between the carbon atom, and so nitrogen has double bond between the carbon atom. So it doesn't make any difference really. So what we can do is we can make nitrogen atom here. This is sigma bond. This is sigma bond. This is sigma bond. Nitrogen. This is sigma bond. This is sigma bond, right? Ouch. 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 Hold on. Hold on. It's all right. This is fluorine atom. This is fluorine atom. Oh, so pi bonds. Okay. This is the P's. Now, pi bond is always formed through sidewise overlapping of p orbital. As you can see, this is sidewise overlapping of p orbital. Okay. In other words, you can draw this structure like this. So this entire thing will show a molecular orbital like this. This entire thing will show a molecular orbital like that. And just label it pi bond. So we have only one pi bond, all right? I hope it makes sense to you. One more thing. We need to write pi bond is always formed through sidewise overlapping or lateral overlapping, sidewise or lateral overlapping of p orbital. Okay. Next, question number 4. Compound S is used in food flavorings. A possible synthesis of S is shown in figure 4.1. So this is basically an alkene. You are reacting, and this alkene is basically symmetricals, and it is reacting with HBr. So we really don't need to follow Markovnikov rule, because Markovnikov rule is always and only applicable for unsymmetrical reagent and unsymmetrical alkene. Since it is symmetrical alkene, so Markovnikov rule is not going to work here. Okay, so basically the structure is going to be like this. We need to add one H here, one bromine here. So this is going to be the structure of Q, right? When Q is treated with potassium cyanide in ethanol, which will serve as a solvent under heat or reflux condition, obviously in place of BRU, we can add cyanide. That's nucleophilic substitution reaction, guys. In short, we can write SN reaction. Now, when cyanide is acid hydrolyzed, so reaction is basically acid hydrolysis, and this CN is directly converted into CWH. But remember, when this acid hydrolysis takes place, ammonia gas is also given off, which he hasn't written this information. So, but for revision purpose, I'm telling you about this, okay? Since ammonia is the only alkaline gas in the whole planet, it accepts proton and convert it into ammoniamine. So the final product is going to be an ammoniamine. Okay, let's talk about this. P, Q, R, and S shows the stereoisomerism. Complete table 4.1 by identifying a tick, the type of stereoisomerism that each molecule shows. Type of stereoisomerism shown by Q is given. This is alkene, and this alkene has double bond in the center, which means it will give you geometrical isomerism, because one hydrogen is here and one hydrogen is there. So similar groups are diagonally attached to the double bonded carbon atom, which means it is trans. And when we have trans, we can have cis as well, right? So this gives geometrical isomerism. Q has one chiral carbon atom, this one. So it has optical. This R has one chiral carbon atom. It is also optical. This compound has one chiral carbon atom. It shows optical isomerism. All right. Give the structural formula of Q. Structural formula 2-bromobutane. It's easy. Structural formula that we can write in this way: CH3, CH. This is Br. This is CH2, and this is CH3. Okay. Name the mechanism in reaction to nucleophilic substitution reaction. Okay. Yeah. Oh my goodness. Now the next is complete the equation for reaction 3. R is represented as this. Okay. Okay. So I'm treating it with aqueous hydrogen ion in the presence of water. Obviously, it will give you C4H9 COOH. Phew. First of all, count total number of carbon atoms here. So we have 4 carbon here, we have 1 carbon here. So we have total how many carbon atoms? 5. So we have 5 carbon atoms. How many nitrogen atom we have? 1. How many hydrogen atoms so far? 9 plus 1, 10. 10 plus 2, 11. And we have 1 oxygen also, right? Over here, we have how many carbon atoms? 5. Since carbon atom is balanced on both the sides, remove carbon atom. Don't remove Acha. Okay. How many nitrogen atom? Obviously, it will turn to an ammonium ion. Okay. So we really need to write it here in the complete equation. Since examiner demands the complete equation, so we need to put ammonium ions here. How many nitrogen atoms now? 1 nitrogen. How many hydrogen atoms now? 9 and 4. 13. 10, 11, 12, 13. Yeah. 13 hydrogen atoms. How many oxygen atoms here? 2. So we need to balance oxygen first. How many oxygen atoms here? 2. How many oxygen atoms here? 1. So we need to put 2 here so that we can balance the oxygen atom. Oxygen balance removed. Remove this. Now total hydrogen atoms here. 9 plus 1, 10. 10 and 4, 14. 14 hydrogen atoms now. And how many hydrogen atoms here? 9 plus 1, 10. 10 plus 4, 14. So hydrogen atom balanced now. Remove them. Nitrogen atom on both the side. Carbon atom same. That's your balanced chemical equation, guys. That's the class of organic. Very, very classy question. I absolutely love this question. Okay. Next part is C. Compound S in T reacts to form organic compound U, which has a single functional group. That single functional group is really, really important. That means it has only one functional group, not more than one. Now this carboxylic acid is reacting with T, converting into U along with the formation of water. Now tell me, in the entire organic chemistry, water is formed, all right? When water is formed, this process is called condensation, right? Or esterification, right? Okay. I don't have really any clue here at this stage what's going on in this reaction. So let's move on to the next part of the information. Table 4.2 shows some data from the mass spectrum of U. We have the relative abundance of molecular ion P. If you remember, in lecture, we have this is molecular ion peak, and according to my lecture, this molecular ion peak gives the information about the molecular mass of the compound. This is M plus 1 peak, and this M plus 1 peak gives the information about the presence of carbon 13 in the mass spectrum. Okay. Now we have abundance of molecular ion peak and abundance of M plus 1 peak. So on the basis of this, use the table to show that this compound U has 7 carbon atoms. Show your working. Okay. So let's apply the formula. N equals to 100 over 1.1. Abundance of M plus 1 peak is 0.55. Abundance of molecular ion peak is 7.2. So number of carbon atom is 7. N is basically the number of carbon atom, guys, right? So what we can do is first write the formula. What was the formula, by the way? N equals to 100 over 1.1. Abundance of M plus 1 peak over abundance of molecular ion peak. Okay. This is M plus 1 peak. This is molecular ion peak. Okay. Now we have 7 carbon atoms here. Cool. I can think now. Let me work. It's sort of analytical skill information. Okay. So this U has 7 carbon atoms. Okay. Whereas this compound S has how many carbon atoms? Let's count. 1, 2, 3, 4, and this one is 5. So this compound S has 5 carbon atoms. Oh my goodness, what a classy question. If this compound has 5 carbon atoms and this compound U has 7 carbon atoms, which means this T contains how many carbon atoms? Obviously 2 carbon atoms. Oh my goodness. Oh my goodness. Oh, that's called analytical skills, right? So this compound contains 2 carbon atoms. Okay, let me work furthermore so that I'll collect the information and then I'll let you know what's actually going on in that reaction. So figure 4.2 shows the infrared spectrum of U. Okay, so from 500 to 1500 centimeter inverse, you will get the fingerprint region in which we have only carbon single bond oxygen and carbon carbon bond, right? So this is 1100, this is 1200. This peak at 1200 centimeter inverse represents carbon single bond oxygen according to my lecture, according to the information given in the data booklet or given in the data table. All right, this is 1600, 1700, and this peak is approximately 1720. So if this peak appears at 1720 centimeter inverse, it's going to be carbonyl group, which is CO. Now this is a peak appears at 3000 centimeter inverse according to my lecture. If this peak appears at 3000 centimeter inverse, obviously it's going to be CH. Now in this compound U, we have these 2 groups, and if you combine these 2 groups, you will get a functional group. So technically U contain C double bond O and C single bond O functional group. Oh my God. Oh my God. What a lovely question. Okay. Now this U contain ester functional group. And ester functional group is always formed when carboxylic acid and alcohol react together, which means this T is basically an alcohol. And 2 carbon atom, this alcohol contains 2 carbon atom, which means this alcohol is going to be ethanol. What a classy sort of analysis. Amazing. I absolutely love with this question. Okay, so whenever carboxylic acid and alcohol react together, esters are formed along with the formation of water. Okay, that's a good question. Good question. Oh, I was talking about this. See, carbonyl has 1670 to 1740 centimeter inverse. but in the spectrum, the peak appears at 1720 centimeters inverse, which is why I've written that. Okay. Similarly, carbon single bond oxygen appears in ester with this frequency range. Since the peak appears at 1200 centimeter inverse in the spectrum, I have used that. I've written that. Okay. So it doesn't make any difference. Anyhow, use figure 4.2 and 4.3 to identify the functional group present in U. Explain your answer fully. Functional group, ester. Explanation. One peak of IR spectra appears at 1720 centimeter inverse, shows carbonyl group. Another peak appear at 1200 centimeter inverse. This means these two groups combine together to give ester functional group. Okay. Okay. T also has a single functional group. T. What is T? Or single functional group. So functional group is basically an alcohol, that is OH group. Okay. And it's proved. Use this information in C1 and your answer to C2 to identify T and U. Draw the structure of T and U in the boxes. Okay. T is basically ethanol. Or since examiner has given so ethanol, that is CH3, CH2, OH. Let's draw the structure of U. I don't have any space. Okay, let me write it down. Let me write this structure. Wait. Let me take the screenshot so that I can make the structure conveniently for you. Okay. This is basically what? S. Okay. And T is basically what? Ethanol. So when you mix together, when they will react together, obviously OH is removed from carboxylic acid and H is removed from alcohol. They will combine together to give you an ester and water. Let me draw the structure of ester. This is CH3, CH2, CH. This is CO. This CO is attached with oxygen. Now this oxygen is attached with CH2 and then CH3. I hope it makes sense to you. And this CH3 remain as it is. So let me draw this structure in a skeletal way, right? In a skeletal format. That's easy. That's not a big issue. Let me draw it. CH3, C, this C double bond O as it is. This CH3 will remain as it is. This is oxygen atom. This is CH2 and this is CH3. Okay. Or we can write like this. This is C, double bond oxygen, single bond oxygen. This is CH2, this is CH3. Much better. Okay, that's the end of this question. Let's move on to the next page. Oh, that's the end of this paper, guys. Thank you very much.